In this video presentation, we will discuss the conditional statements and how to construct its truth table. Let us recall the example, if I am a Tomasian, then I enjoy flooded area. The conditional statement, if P then Q, means that P is called the hypothesis, the premise or the antecedent, and Q is called the conclusion or the consequence. For example, if you say that I am a K-pop, then I understand the Hangul. It means that your hypothesis is I am a K-pop and your conclusion is you understand the writing. So that is if P, then Q. The conditional statement if P then Q is not limited to that translation. You can also use the following. P is sufficient for Q, Q if P, Q is necessary for P, or P only if P. You can also use Q when P and Q follows from P. Now, let's try to construct the truth table. For the conditional statement if P then Q, it is true on the condition the P holds. Meaning, the conditional statement if P then Q is true if the conclusion or your Q is also true. Also, the conditional statement is true if both your hypothesis and conclusion have the same value. So in this case, for the first row, if P is true and Q is true, then the conditional statement is also true. In the second row, since your P is true while your conclusion is false, then the conditional statement is also false. For the third one, even though your hypothesis is false, but since your conclusion is true, then the conditional statement is also true. Lastly, since both hypothesis and conclusion are false, then your conditional statement is true. For example, construct the truth table for if not P, then not Q. So the first thing that you need to do is to construct the truth table for not P and not Q before you get the conditional statement. So in this case, for the first row, since both not P and not Q have the same value, its conditional statement is true. For the second row, since your conclusion is true although your hypothesis is false, then your conditional statement is also true. In the third row, since your conclusion is false even though your hypothesis is true, your conditional statement is also false. Then lastly, since both your hypothesis and conclusions are true, then your conditional statement is also true. Take note that if Q then P is the converse of if P then Q. Also, if not Q then not P is the contrapositive of if P then Q. Lastly, if not P then not Q is the inverse of if P then Q. The biconditional statement P if and only if Q is true when both P and Q statements are the same. So for the truth table, the only time that the biconditional statement is true is if both P and Q are the same value. So that is on the first row where P is true and Q is true, then the biconditional statement is also true. The second and the third row have different values, so the biconditional statement is false, whereas the last row where both hypothesis and conclusion is false, we get a biconditional statement equivalent to true. Let's look at this example. Construct a truth table for P if and only if not Q. So first, you need to get the values for your not Q, then get the biconditional statement of P as your hypothesis and not Q as your conclusion. So the first row will have false, the second row will be true, the third row will be true as well, while the fourth row is false. So let's try this example. Construct a truth table for if P and Q, then if P, then Q. So first, create a column for P and Q, or the conjunction of P and Q. So from the previous discussion, it will give you true, false, false, and false. Then, construct the conditional statement if P, then Q. That will give you true, false, true, and true. Lastly, to construct the final column, you get the conditional statement of the third column and the fourth column. That will give you the values T, true, true, and true.